Welcome everyone, thank you for joining us today. The focus of this presentation is on using the GeoWeb 3D confinement system and installation best practices. This presentation assumes you're already familiar with GeoWeb geocells and their integral components, so bypasses some basic background information to focus on next level and intermediate techniques. Please see our on-demand resources available at prestogeo.com for a deeper understanding in any one of the applications covered today. Or please reply to the follow-up emails that will come shortly after the presentation. I'm Jose Paulo George, or JP, the business manager with Presto Geosystems. We manufacture industry-leading erosion control, stormwater management, and porous pavement products, all made in the upper Midwest of the United States. Through an extensive national and international distribution network, we offer technical and site support as well as free project evaluation from our in-house engineering team. Today's presentation will help you leverage our over 40 years of geocell experience and get installation best practices and technique tips. So here are some of the things I hope you get out of today's presentation. Understand the benefits of using a soil stabilization system for the major applications of load support, slope protection, channel armoring, and earth retention, with some fundamental installation steps for each. Gain technique tips to make installations more effective and efficient, and how to train your team to set them up for success and ensure the best project outcome. During the presentation, if you have any questions, please type them in the chat window and we'll answer them after the presentation. Presto worked with the U.S. Army Corps of Engineers to develop geocell technology in the late 1970s, and we've been innovating ever since. Our products are used in nearly 200 countries and in every state of the U.S. We go beyond simply providing a product, all with an eye toward providing a complete solution for your project needs. We're going to start out with a quick recap of the GeoWeb 3D soil stabilization components, and then we'll get into technique tips for installing each of the major application types. The three primary elements of any geocell system, cell walls, internal junctions, and connectors, must perform uniformly as a complete system. Any incremental improvement in one characteristic is only valuable if a complementary improvement has been made in the other components of the system. GeoWeb is manufactured using a proprietary blend of high-quality virgin high-density polyethylene, and our formulation has stood the test of time for more than 40 years and contains no fillers, unstable polymer combinations, or exotic alloys. For most typical sites, GeoWeb will retain its durability for greater than 100 years, with lab testing indicating 149 years without degradation, even at full exposure to elements. We stand behind our numbers so you can deliver certainty in the solution and build with quality materials you can trust. Made from high stability inert materials, GeoWeb geocells are your permanent stabilization solution and will not degrade, leach, or release microplastics into the environment. GeoWeb does not contain any intentionally added PFAS, and based on this understanding, GeoWeb is not expected to pose a risk of release of PFAS compounds into the environment. GeoWeb is manufactured with premium high-density polyethylene resin with no fillers, alloys, or compatibilizers, and our base resin is the same material used in environmental applications like geomembranes and other environmental barriers to protect against the spread of harmful toxins, and our products have been third-party tested by accredited geosynthetics laboratories, confirming long-term stability against environmental factors such as weathering and oxidation. GeoWeb and our accessories are 100% made in the USA under strict quality assurance and environmental control processes, and are sure to comply with all requirements for Build America, Buy America, and the Infrastructure Investment and Jobs Act. The system components are all the supporting pieces that help the GeoWeb protect the surface and subbase layers and also ensure relatively uniform performance of the interconnected system, thereby protecting against damaging effects of non-uniform deformation and differential settlement in response to applied loads. Presto's GeoWeb system components increase strength and speed of installation, each of them offering some additional best practice options that we'll mention in context with installation examples. Let's begin with installation techniques for the GeoWeb load support system. The first pro tip is to use a quality engineered solution best suited for your project needs. Uniform and consistent proven performance and durability, especially in demanding site environments, will be well worth it in the long term. And our in-house engineering team can help you choose the right geocell based on site conditions. Soft subgrades like the harbor wetlands seen here are where GeoWeb geocells shine. So here's a quick overview of that installation process. You start by getting the subgrade ready, then geotextiles or other planar geosynthetics as required by design. Next, lay out the GeoWeb sections. The GeoWeb sections are then interconnected. The AtraKey connector is shipped in convenient to hold 3 packs per case, as you see in the photo on the left. The mini pack can be carried to where the connections are made, and this is a good technique tip. A pro tip is to use contractor pouches or aprons for a hands-free way to hold and carry the keys and make the fast connections even speedier, as you see in the 2 photos on the right. The specific engineering values of the AtraKey will ensure the system holds up to loading over time without the corrosion as seen in staples, the failure of underperforming cable tie systems, or cumbersome multi-piece connectors. You'll want to hold the GeoWeb sections open for infilling, either with temporary stakes or by filling a few cells around the perimeter. We'll see an example of that in just a few more slides. The infill is placed, spread, and compacted with an appropriate wear surface. According to design, that could be an unpaved surface, a flexible pavement, or a rigid pavement atop the GeoWeb. Let's look at some examples from an unpaved load support system first. An aggregate surface has advantages in saving pavement costs, and with the GeoWeb system filled with open graded base course, you can design a system that allows stormwater infiltration and provides stormwater storage. This was a project for a sawmill in Canada. Spring snowmelt and fall rains cause flooding and soft, challenging ground conditions in the infeed area. In this photo is great to see how the GeoWeb was placed and held open with stakes at the perimeter, and then the infill was spread. Presto worked with the project owners to develop and design to manage stormwater and snowmelt while providing stabilization and support of the heavy loading over soft subgrades. A 6-inch or 15-centimeter GeoWeb load support system with high-strength woven geotextiles was installed, with infill designed to promote stormwater infiltration. Here we see the GeoWeb sections expanded, and the workers are just beginning to connect panels side to side with the AtraKey. This design included a permeable base layer with less than 10% fines for stormwater purposes. The GeoWeb system provides a strong reinforcement layer for the constant heavy loads that the mill infeed area sees daily. Here we see the infill being placed, and good technique is to limit the drop height to 1 meter or less, about 3 feet, to ensure the empty geocells don't fold over and are evenly filled. GeoWeb created a smooth platform that eliminated rutting and constant maintenance, and both the project owners and the installers were pleased by the ease and speed of installation thanks to AtraKey connectors. Here we also see a good technique tip with crews working in parallel. On the far left, placing of the infill by the excavator, while workers expand and connect the new sections of GeoWeb. Far right, we see the roller compaction of the infill. Having a crew with well-defined roles allows this kind of work in parallel, an installation best practice, and makes for an efficient installation all around. To ensure everyone knows what to do, take advantage of contractor training available, including a construction resource package, training guides, videos, webinars, and even in-person or virtual seminars. See prestogeo.com or any of our trusted distributors for more details. This is a good GeoWeb load support project to demonstrate using the GeoWeb as its own site access during construction. This was a project for Duke Energy in Florida to install new transmission towers through wetlands. Hurricane winds demolished over 100 towers, all of which had to be restored over this extremely soft subgrade. The saturated sand could not support any type of vehicle loading. An enhanced woven geotextile was placed over the subgrade, adding an additional strength layer to the system and allowing water movement without getting clogged by the sandy material. The GeoWeb system was used for access and maintenance roads, as well as pads around the towers. So as before, the GeoWeb was expanded and held open with temporary stakes, then infilled by pushing via dozer. The GeoWeb panels were filled with a low-quality aggregate that could easily be sourced and transported to the remote locations for this project. Once the panels are filled in, both wheeled and tracked equipment can drive over the systems easily, even when the infill material is sand or other low-quality stone. Again, we see how the GeoWeb panels act as their own access road. You just keep filling up the cells in front of you. No need for additional temporary roadways. This is a great construction time and resource saver. One important advantage for any unpaved surface utilizing GeoWeb stabilization is the use of open graded base cores. Since we do not need fines to achieve compaction for base stability, the system will function like an on-site detention basin, storing water in the void space of the GeoWeb infill. As a general rule of thumb, a 3/4 inch or 19 millimeter open graded crushed aggregate has a void space of approximately 35%. So you can calculate how much water you can store to potentially reduce your stormwater runoff and ultimately have the ability to reduce stormwater pond volume and land requirements. There are many ways to place the infill. A rock slinger is one of them and allows precise placement for fast, even filling, while controlling the height from which the aggregate falls. Buckets with extendable booms can also be helpful, though a push with a dozer or backhoe will work just fine. The GeoWeb 3D system is beneficial under hard pavements, including asphalt, reinforced concrete, and roller compacted concrete, especially in areas with soft subgrades or with drainage issues. Now on to some technique tips for those types of installs and for large-scale projects. This project for BNSF is a good example of base stabilization with technique tips of beneficial reuse of on-site materials, staging tables, and site layout. Those are all key takeaways with this big quantity. This is for an auto storage yard for BNSF by the Seattle International Airport. It was a 25-acre site with soft subgrade, and the original design included 2 layers of biaxial geogrids. After bidding, the cost came in higher than the budget allowed, so the engineer contacted us and we did a value engineered solution. In the far left of the screen, you see one of the stockpiles of the salvaged material, and this beneficial reuse of material saved a significant amount of material costs and sped up the construction time. Here's a best practice pro tip: staging tables, as staging is important for any large project. Here we see the use of staging tables where adjacent panels are connected prior to being expanded and placed across a prepared subgrade. Each panel has an area of about 270 square feet or 25 square meters, and this contractor is using the tables to connect 3 panels together side to side, providing a total area of over 800 square feet and about 75 square meters. The staging tables allow the workers to stand while connecting the panels for a quicker and more ergonomic pre-assembly. The panels are then transferred for installation, with typical installation rates about 3,000 square feet or 280 square meters per hour with a crew of 3. And again, work can run parallel with one crew laying out the site, another installing the GeoWeb, and another filling and compacting for your best efficiency. Another technique tip important for large projects is to prep the site layout. This contractor wanted square panels for the entire installation, so they surveyed and staked the corners for each GeoWeb panel over the 25-acre site. Once the GeoWeb panels were filled, they just pulled the stakes. Similar to using stretcher frames to open panels to a set distance, this made such a large installation go very quickly and very efficiently. Here we see a picture of the installation ongoing with a 4-inch wear surface to allow construction access during the installation process. Again, using the GeoWeb system as its own access road. At the far left, you see where the contractor stockpiled the on-site sandy soils to mix with crushed aggregate and save on construction costs. The expanded and connected GeoWeb is mid-screen, and the filling then compacting as we move to the right. Again, this work in parallel across the site allows for an even more efficient installation process. Here we also see the stakes for the site layout from the site survey. These technique tips made for a very efficient install for such a large project. Here we see the dump trucks just back up to the GeoWeb, dumping the infill material, and then it's spread with a bulldozer. The material supports loading immediately after filling, no cure time needed, and no special weather requirements. Again, serving as its own site access road for construction. And here's the finished surface. So here's a quick recap of some of the technique tips and best practices mentioned for GeoWeb load support installation. You can see prestogeo.com for installation guides, videos, case studies, and additional resources, or reach out to us or any of our trusted distributors for more installation tips and installation and site support. Next, we'll have some installation techniques for GeoWeb slope protection systems for slopes and shorelines. whether it's a slope adjacent to railways, embankments along a railway or roadway, a mine slope reclamation, geomembrane protection, shoreline revetment, or other slope application. There are ways to make the slope protection system's installation safer, easier, and faster. Here's a quick overview of the installation process for a slope system with anchor stakes. First, prepare the subgrade and install a geotextile if part of your design from crest to toe. Then anchor the GeoWeb at the crest. Note the horizontal turn at the top. Expand your sections down slope, connecting side to side as possible on the crest and the remainder on slope. Continue installing anchors at the frequency recommended by the design and at the toe of the slope. The ATRA anchors hold the GeoWeb to slope and penetrate into the ground. If corrosion resistance is required due to project conditions, Presto has an HDPE ATRA speed stake designed to work with the GeoWeb and offer higher resistance to extraction than rebar or J-hooks. Once the system's properly anchored, infill from top of slope down. Here's an example of a railway slope project in Montana with the use of ATRA anchor stakes. Aggregate infill was chosen for both sides of the embankment for erosion control, plus a low maintenance slope cover. This project shows the benefit of material delivery at the top of the slope, greatly reducing the handling and truck traffic into surrounding areas. When such delivery from the top is possible, it makes for a faster, safer, and easier installation. Here we see the workers installing the stake anchors to keep the GeoWeb section in place. And we see the panels being infilled with crushed aggregate. Infill is done from the top down to prevent panel overstretching. Rock slingers, as shown in the load support section, also work well for this top-down infill process. Just a close-up picture showing the GeoWeb panels were extended under the bridge abutments. And here's a picture of the finished slope. Here's another example from a mine slope with ATRA anchor stakes using waste rock as the GeoWeb infill. This project is great to see the work in parallel and an ATRA GAD to drive anchors, with one worker measuring and marking for stakes, another placing them for anchorage, and another using a pneumatic hammer with ATRA GAD to drive them. The site also used an on-slope delivery tote for safe, expedient restocking of the anchor stakes. This is a great pro tip for your slope work. And here with the infill placed and the slopes stabilized with GeoWeb geocells. Additional in-field adjustments can be made following a stake pull-out test with a fish scale to ensure actual values match the geotech report and information used in the evaluation's calculations. This quick double check can give you some extra peace of mind for your staked slope protection. Some slope protection systems are over a geomembrane or other liner that cannot be punctured, are on very steep slopes, or over rocky soil. In those cases, a system with tendons and load transfer devices is used. Here's a quick overview of that installation process for ATRA-Tendon clip installations. Prepare the subgrade, install the geotextile as recommended. At the crest, insert tendons through the cell wall eye slots and secure the tendons to the crest anchorage. Only the ATRA-Tendon clip is specifically designed to fully transfer safely and securely the forces placed upon the geocell. Every accessory and every feature has been designed and tested to specifically work together. So we go from problem to design to construction solution with a system where the modeling replicates real-world forces. We're not just throwing washers on a cord. Install the ATRA-Tendon clip load transfer devices as per design, and at the crest of the slope, then expand your sections downslope. Connect sections side to side and end to end as possible on the crest, the remainder on slope. Anchor the toe with either ATRA-Tendon clip or stakes, according to the design. And once the system is properly anchored, infill from top of slope down. Now let's see that process with a couple of project installations, for example. This is a vegetated slope project at a solar farm and allows us to show some great step-by-step install pics while pointing out some best installation practices with ATRA-Tendon clips. The solar site included a sloped area leading to a large detention pond for stormwater management. GeoWeb helps stabilize that slope and control erosion. Tendons were laid out, measured, and marked per design, then inserted through the eye slots on the slope crest, with sections being built on this flatter ground where it's safer and easier to work. A suspended rod through the tendon spools is a good technique tip that can be helpful when marking and inserting the tendons. For this GeoWeb slope protection system, a PVC pipe was used as the dead man anchor at the crest of the slope. And here's the connection of the tendons to that pipe. There are many ways possible to tie off the tendon to the crest anchorage, and the specific knot type is up to the contractor to determine, as long as the knot is secure and permanent. One recommended knot is known as the trucker's hitch knot and is a self-binding knot common for tying loads to secure them to a fixed point. It can be tied anywhere in the standing part of a line and can create high tension lines that are used to safely secure heavy loads. This is what that knot looks like. But again, one of many possibilities. The pre-assembled sections, once connected to the crest anchorage, are then hung over the slope like a curtain and extended down slope. With the GeoWeb system and tendons and ATRA-Tendon clips, you can pre-measure, mark, and know the layout for pre-assembly based on your project design. Let's look at a particular project to underscore the value of that pre-assembly and show you some pro tips for how to do it. This tendon GeoWeb slope project highlights the pro tips of that marking and pre-assembly, using staging tables for pre-assembly of the GeoWeb ATRA-Tendon clips and tendons, and gives you an ergonomic and efficient process all around. An assembly line with staging tables allows that pre-building of the slope protection sections, and then the pre-assembled panels are marked for location and then taken to install, ready to hang in place on the slope. The pre-assembly means much work is done on the flats instead of on the slope side, much safer and more efficient for your workers. So here's a quick recap of some of the technique tips and best practices mentioned for a GeoWeb slope protection system installation. For installation guides, videos, case studies, and additional resources, please visit prestogeo.com or reply to our follow-up email for more information. Our next set of installation techniques will be for the GeoWeb earth retention system. Here are the two different wall options in cross-section. A gravity wall where longer pieces of web at the bottom get shorter as you go up, and the weight of the infill GeoWeb provides that retention. Or a GeoGrid reinforced wall, where the GeoGrid provides the retention and GeoWeb functions as a fascia alternative. In either case, again, the front cell can be filled with topsoil and the back cells or reinforced zone can use any drainable material. The ATRA wall key is the major component for a completely integrated earth retention system and is used to connect the adjacent GeoWeb retaining wall sections through the material eye slots. The ATRA wall key includes an integrated washer at the base of the handle for coverage of the eye slots, frictional barbs for an improved interlock with the GeoWeb sections, and an ergonomic handle with S-shaped contouring for ease of installation. Formulated to withstand weathering and ultraviolet radiation, the ATRA wall keys will not corrode or photodegrade even when exposed to harsh environments. Securing sections with the wall keys is faster than using staples or zip ties, requires no tools, and can be completed by one installer with one easy turn. Here's a quick overview of the installation process for the GeoWeb earth retention system. As with other applications, prepare the subgrade and install any geotextiles as recommended by design. The step of expanding the GeoWeb section is best done with stretcher frames or stretcher bars. Pro tips in their own regard, so we'll come back to those in detail in a bit. And then the interconnection of sections as another pro tip option with the ATRA wall key, color matched to your fascia. For vegetated walls, topsoil in the front cell and any granular drainable material in the back. And for a geosynthetic reinforced wall, add the GeoGrid as recommended by design and shown in step 10. For a vegetated wall, either reinforced or gravity, go on to step 11. And while reinforced walls are not limited in height, it's a good technique tip to use multiple tiers of shorter height walls rather than a single wall tier. This is because the length of the reinforcement may become too great with just a single tier. That ratio of wall height to reinforcement length is about 70%. So a 6 meter or 20-foot high wall needs about 4¼ meters or 14 feet of reinforcement. Or a 40-foot high wall needs about 28 feet of reinforcement, and so on. You get the idea. Using these shorter tiers allows you to keep the reinforcement length reasonable while still achieving your overall required height. GeoWeb walls can be vegetated or non-vegetated with concrete or crushed aggregate as infill. This wall is benched and stepped back, and we see the ability to change batter angle over a short distance. We'll offer a pro tip for batter angle in just a bit. The GeoWeb earth retention system offers some great benefits beyond just stability. Aesthetics and cost are compelling reasons, but here are some others. GeoWeb can also help reduce urban heat island effects and can help green up your urban areas. GeoWeb walls are environmentally friendly due to their no maintenance vegetation and their ability to capture stormwater runoff. Using local grasses and flowering vegetation will help ensure easy growth with a natural look, and the Ettrick wall keys are color matched to your fascia. Installation of the GeoWeb wall system is fast and materials are lightweight and easy to assemble. GeoWeb MSE walls are both less expensive for materials and for labor compared with traditional MSE walls such as masonry walls or Gabion block walls. And compared to many other wall systems, GeoWeb walls have a lower carbon footprint for manufacturing and transportation. They can help with green infrastructure and low impact development plans for a project site as well. Visit prestogeo.com for more information or talk with any of our engineers in-house to help see how we can save for your project. One of the most significant benefits of GeoWeb walls is its relative lightweight compared to concrete MSE walls and its ability to tolerate reasonable differential settlement. So building over soft soils or areas where differential settlement is a concern is not a problem for GeoWeb walls, as they can handle several inches of differential settlement. This is vital for areas with saturated soils. Here we see a GeoWeb wall being constructed in close proximity to extremely wet rice fields in Japan. Using the GeoWeb system can help avoid expensive and time-consuming activities such as surcharge loading a site, which often has to happen when differential settlement is a concern. The time required for the surcharge loading may be reduced or even eliminated when using a GeoWeb wall. It also reduces the amount of visual inspection maintenance and repair over the lifetime of the wall structure, since the GeoWeb panels can accommodate much more movement than any masonry wall. GeoWeb walls perform well in strong seismic areas and with live traffic loading. It's always necessary to consider live and dead loads that the wall will experience during construction and over time. Dead loads can be buildings or the soil slopes above the wall. Live loads are for construction traffic and long-term vehicle traffic if the wall is below a road or driveway. When possible, the load should be placed away from the edge of the wall or the fascia. If not, the design will need to be robust enough to support and withstand that live and dead loading. Having traffic barriers at the top of the wall will help keep the loads away from the front face of the wall system, which will help with the design. GeoWeb walls work well with integrating traffic barriers and infrastructure, such as the sonotubes and large pipe culvert seen here. There's no loss of structural integrity because of the continuous web connections with the Atra wall key. GeoWeb sections can be easily trimmed to fit culverts, sonotubes, or other obstructions. Let's get into more tips for fitting and field work. Building a stretcher frame is a definite best practice for geocell retaining walls, and we have plans for wooden ones, ideal for walls with a constant cell size, such as most reinforced walls, or expendable ones that are better suited for gravity walls that have more cells at the bottom and less as the lifts are increased. Check out the Installation tab at prestogeo.com to download the full construction resource package or just the stretcher frame plans. While stretcher frames are great for a straight wall, a pro tip is to use stretcher bars for any curved areas. Our installation guides have plans and diagrams for both, and now we'll look at some step-by-step wall builds so you can see them put to use. Most of the examples we'll show have wooden stretcher frames, but remember they can be made out of PVC or other materials and can even be adjustable like this example. Use what works best for your site needs. And if you're not sure, talk to our team or any of our trusted distributors and we're happy to walk you through it. Now let's see the steps of a GeoWeb earth retention system being built as part of a vegetated stacked channel. Preparing the footing for the GeoWeb wall. And on the right, you see the footing layer of GeoWeb installed with granular infill placed. And you see the stretcher frames and infill process. A pro tip is to have a portable compactor on level with your build and compact as you go. Here are the stretcher frames from another angle. The stretcher frames are placed spikes up, and then the GeoWeb is placed over your stretcher bar. Once the section is open to optimal size on the frame and GeoWeb are flipped over, making sure the fascia panel faces the proper way for your site install. Once the section with frame is in place, infill can be placed and then the stretcher frame lifted away. Here we see the frames lifted away and reloaded, far left, getting ready for the next layer. Don't forget to compact each layer as you go. And the process repeats, going down the line, connecting panels side to side, and working in parallel for an efficient installation. And as one side of the stacked channel was completed, onto the other, also using stretcher frames. And here we see the newly constructed GeoWeb walls on either side of the watercourse. And here again, as vegetation begins. The front fascia cells were seeded with a native plant mixture and an aggregate topsoil mix. Notice the slight curve in the wall towards the top of your screen. When your wall has to curve beyond that gentle turn, stretcher bars are a best practice, as they'll hold the wall cells open to the optimal expansion while making that consistent curve radius needed. Note the portable compactors to compact the foundation layer. In this slide, we see where the wall path transitions from straight to curve with the stretcher frame used for the straight portion and in conjunction with the stretcher bars. The process for stretcher bars is similar to a stretcher frame, only in a curve and no flip needed. See our installation resources, including videos particular to placing stretcher bars and other pro technique tips on our YouTube channel. Drainage is a very important topic that needs to be addressed with any MSE wall, including the GeoWeb wall system. Hydrostatic pressure buildup and improper drainage behind a wall face is the leading cause of wall failure, no matter the type of wall. The GeoWeb system is better equipped than impervious walls such as concrete block walls because by its nature it allows for water movement throughout the system. However, even with this, it's crucial to understand your specific site conditions and ensure hydrostatic buildup is mitigated. One of the best ways to mitigate that hydrostatic pressure is with a drainage pipe installed behind the GeoWeb panels. This could be a perforated pipe wrapped in a geotextile to prevent clogging. This type of drain system is a best practice pro tip you want to be sure to include. The drain pipe should daylight in an area that can manage the collected water. The pipe can either come straight through the front of the wall, like shown here, or can end at the side of your wall, depending on what works best for your job site. It's also important to make sure that wherever the pipe drains, is set up such that excessive erosion will not occur at the outfall, which would lead to undermining of the wall at that point. This is the most common type of drainage mitigation. The drainage system needs to be designed by your project engineer and can include as many pipes as necessary to ensure that water is properly collected within the wall structure. Using a clean aggregate and other good drainable soils as the infill and backfill can also help with drainage concerns. If you know there's a place for water to flow, such as the groundwater system or a nearby lower elevation creek, allowing the water to drain straight through the GeoWeb wall is an option. The material used in the construction of the wall will have to be sized for the task, so using an aggregate mix with low fines content is always a good choice. Sandy soil mixes are also good for drainage. You want to avoid using clay or silty soils, which will impede drainage and cause pressure buildup behind your GeoWeb walls. A drainage trench above the wall can help route surface water away from your wall so the structure does not become oversaturated. Here's another issue to consider along the lines of drainage. If your location is an active channel with flow, that water can be rerouted, and here's a stacked wall channel example. Bypassing the construction area, and here's that channel after construction with the vegetation starting to establish. And again, a few years after install, invisibly yet reliably protected. If you prefer not to bypass or reroute the water, it is okay to construct the system in water too. Just maybe not as fun for your install crew. Stepped walls are a bit of an advanced install, needing some technique and some extra planning. Our full installation guide gives examples of calculating offset dimensions for a GeoWeb wall on a stepped base. Useful for interesting walls such as this. The engineer used 3 different wall batters and multiple stepped areas to make the GeoWeb fit the site. We mentioned drainable fill a few slides back. You may also consider grouting the front cells or filling them with concrete when high flow is expected, like this highway retention pond. Or a mix of medium, as you see in this project, with aggregate fascia along the pathway and topsoil for vegetation elsewhere. The careful alignment of cells vertically from one lift to another is a good pro tip and worth the extra care. Not only will your wall be more aesthetically pleasing, especially important if it's not vegetated, but the alignment will help prevent potential material loss in the fascia cell that may occur if your cells are misaligned. Here's an example of good cell alignment. And another. Another technique, best practice and pro tip is to check the wall batter as you build. Here we see construction in process with batter check stations along the way. No problem with compaction or around curves, as the same setback angle is maintained. Notice the cell alignment vertically from one lift to the next in the curved area in the photo on the right, and how the batter checkboards help keep consistency. Batter checks are a good pro tip to build beautiful, long-lasting GeoWeb retaining walls. A proper wall batter with slight setback is not only nice looking, it can also ensure good vegetation for your wall. We typically recommend a setback of about 5 centimeters or 2 inches for a vegetated wall. Here we see the wall structure is constructed with that slight setback to allow topsoil fill in your front cells. The wall can be seeded either by mixing the seeds in your soil before installation or by hydroseeding once installation is complete. And then this turns into this. To design your own GeoWeb earth retention system, request a copy of the MSE wall design software from our webpage, prestogeo.com, in the Design tab. Otherwise, activate our in-house engineering team for a free project evaluation and let us do the heavy lifting for you. Here's a quick recap of some of the technique tips and best practices mentioned for the GeoWeb earth retention system and its installation. Visit our website for installation guides, videos, case studies, and additional earth retention resources. The following set of installation techniques will be for the GeoWeb channel protection system. As the install process for channel projects can be very similar to many slope systems, and as we touched a bit on stacked channels with the GeoWeb walls, we'll focus only on aspects not yet covered, such as hard armor protection and its applicable technique tips. First, here's a quick recap of some of the technique tips and best practices mentioned for GeoWeb slope protection system installation. These slope and shoreline tips still apply to the GeoWeb channel armoring system, so keep them in mind as we talk about channel installations. For efficiency's sake, we're only going to be highlighting new ones to this section. So the GeoWeb channel system installation steps are similar to the slope install initially. Though as you expand the sections downslope, you must note the water flow direction, and the GeoWeb should be towed in at the upstream termination. This is an important technique tip, and one you should also do at transition areas if your channel goes from hard armor to competent rock, for example. Key in or tow in at that transition. Talk with our design team for additional details on that, again, specific to your site needs. Then continue installing anchors at the frequency recommended by the design. And once the system is properly anchored, infill from top of slope down. If it's a concrete channel armoring install, it may work best to fill the bottom of the channel first, then your side slopes. We trust the GeoWeb system and have the experience and research to back us. Presto did a big series of channel armoring tests at Colorado State University under the direction of Dr. Chris Thornton. CSU is considered one of the top hydraulic research facilities in the world, and their lab has a couple hundred feet of static head, about 80 meters, to achieve extremely high velocities and shear stresses in both their indoor and outdoor flumes, with impressive results for vegetated, aggregate, and concrete-filled GeoWeb channels. Let's dig in with some technique tips for each, starting with vegetated channels. Here's a technique tip for using the GeoWeb system along channel side slopes. Notice how the panels just cover the sides, not the channel bottom. The GeoWeb panels will allow for vegetation to grow up in both embankments, which will not normally be underwater. Notice the bright yellow liner below the panels. In this case, using the tendon anchorage system will hold the GeoWeb panels in place without damaging that liner. And you see the white tendons coming down slope towards the top of your screen. Even with the liner beneath, vegetation can still grow thanks to the soil held within the cell walls of the GeoWeb panels. As this stormwater overflow channel becomes flooded during storm events, the side slopes are protected and the channel will do its job. Here's a project near Phoenix, Arizona that can highlight some new technique tips for us and show an aggregate channel example. Heavy runoff from intense storms was leading to erosion and flooding in adjacent subdivisions. Several existing embankments and channel sections failed under 100-year storm events. Here's a pro tip particular to channels. One of the really nice things about using GeoWeb is it allows for adjustments. Here you see the GeoWeb cell wall depth was reduced from 8 inches to 4 inches. The second half of the channel from the main inlet was subjected to reduced flow rates and lower shear stresses. Because of this, less protection was required, so a shallower GeoWeb panel was used, which saved on cost and installation time while still meeting the performance requirements. A seamless transition was made by connecting the 30V8 to the 30V4, as you see here. This is only possible due to the strength of the Atra key. Using staples or zip ties or multi-piece connectors will not provide enough strength, and the panels will separate over time. The GeoWeb panels are very flexible and can be easily cut in the field to allow for pipe penetrations, as we saw with the sonotubes in the GeoWeb wall portion. And again, no loss of integrity with the system performance. Here we see some drainage pipes from a nearby detention pond. It's very simple to complete field cuts of the GeoWeb panels and accommodate structures like these, so there are no areas left unprotected. The area right below the drainage weirs should be built more robustly, since this is the area with the highest potential for stone washout due to turbulence of water coming out of the pipes. The infill was waste rock from a nearby quarry and is not of the greatest quality, but that's all right. When using GeoWeb, the rock does not have any requirements other than size and that it be angular, so money can be saved on material and hauling costs. The only infill material to avoid is river rock and rounded stone, since it does not lock up and will be scoured away over time. The advantage to GeoWeb aggregate channels is construction equipment can drive on the GeoWeb areas immediately after infilling. This is allowing the GeoWeb channel to be used as an access road for construction, as you see in the photo on the left. And here's the installation under typical flow conditions. You see the technique tip of adding drop structures, and several were designed throughout the channel to reduce velocity before reaching the end of the channel, so the water will be transported to the groundwater system. With the aggregate protection system, there is little to no maintenance required, since the aggregate is confined and won't need to be replaced, and the channel is large enough to accommodate large storm events without overtopping. Outfall areas can be challenging because they typically have high velocities and shear stresses, more so than the channel as a whole. The water in these areas is turbulent rather than laminar and smooth, which can cause its own set of problems. Using the GeoWeb system can help mitigate these concerns, especially when concrete is used as the infill, since turbulent flow and high velocities are not an issue. For concrete channels, another pro tip is to use the GeoWeb as the formwork and have it contour as needed to your outfall structures. The GeoWeb channel system is flexible enough to modify the structure, and here's a technique tip of grouting in large riprap in a rockfall area in a mine closure channel. Or you can add energy dissipators, again, integrating them directly with the GeoWeb system and directly as part of your channel design. If you want a vegetated channel but have strong flows, a pro tip is to include surface protection over the panels, such as a TRM or core fabric, as you see here. This is intended for short duration events rather than continuous high flow. If you have high flow or shear stresses for your channel armoring, you may likely be using a concrete infill for your GeoWeb channel, like this mine closure channel in Guatemala. Here we see the technique tip of filling the channel bottom first, then the side slopes. This is to ensure the system stays in place as no stakes are used, but also facilitates construction, as crews can traverse the channel bottom as they finish the side slopes. Again, for the side slopes, fill from crest to toe. This channel had a drop structure rapids incorporated, and here we see the joining of the rapids to the rest of the GeoWeb channel with a drone view of the rapid structure here. And a pro tip for concrete channel infill is to use a concrete boom pump, as you see here, or a line pump if you have an install that's easily accessed horizontally. Another important consideration and technique tip is to include site access along the channel crest that can support the loading of cement trucks and other heavy equipment. Temporary access mats can help if design constraints will not permit access as part of your design, and can even be placed in water. So here's a quick recap of some of the technique tips and best practices mentioned for a GeoWeb channel armoring system installation. For installation guides, videos, case studies, and additional resources, visit prestogeo.com. We deliver quality and over 40 years of expertise, guaranteeing that each shipment meets or exceeds our specs, so you can deliver certainty and build with materials you can trust. No disclaimers or concerning fine print, and the best quality and service in the industry. Part of our complete solution is our technical assistance, and the engineering team here at Presto Geosystems works closely with landscape designers and engineers, offering a free project evaluation service for any road, embankment, or erosion control project. The form is on our website, prestogeo.com, and you fill it out with as much information as you have, including attaching documents such as geotech reports, project site pics, or other info, and it comes directly to us. I would also like to introduce our web-based software, PrestoGeo P3, where you can plan projects yourself within this portal. The software offers a suite of geotechnical calculation tools designed to support engineers, contractors, and project owners in completing value engineering evaluations using GeoWeb GeoCells and GeoBlock and GeoPave porous pavements. Check out the software at prestogeop3.com. We have made it faster and easier for you to obtain your PDH certificates, and with our webinar dashboard, you can easily view our library of webinars and download PDH certificates for on-demand webinars completed. Your webinar dashboard will keep a record of on-demand webinars completed, along with PDHs earned. Please note that certificates for live webinars are managed separately from the on-demand webinar dashboard, so you won't find your certificate from today in there if you're joining us live, but you will receive an email from GoToWebinar within the next 2 hours containing the download link to obtain your PDH certificate. In 2 to 3 days, you will also receive a separate email from Presto Geosystems with more information about accessing on-demand webinar dashboard offerings with other helpful resources. If you do not receive either of the previously mentioned emails, please check your spam folder and follow up with us accordingly. Here are my contact details, and that's our presentation. I want to thank you for attending and remind you can send questions to us anytime at info@prestogeo.com. Go to prestogeo.com for a wealth of information, and don't forget to view our YouTube videos found by clicking on the YouTube icon in the upper right corner of our webpage. If you have a technique tip that we didn't mention, please let us know. We would love to hear from you. Quick housekeeping note, as an attendee, again, you'll receive that PDH certificate within the day, and then a follow-up email from us with helpful links along with the link to this recorded webinar. I'll answer questions next, but again, if you have questions that I don't get to or a pro tip to share, please do respond to that follow-up email or info@prestogeo.com. Again, we'd love to hear from you. I know we're a little over time already, but let me get to some of our questions and respond accordingly. All right, first question, going in order taken. Why was there no geotextile beneath the GeoWeb? It's not always required. It depends on the evaluation and recommendations. If you have the same subgrade soil as your infill, for example, you might not necessarily need a geotextile Sometimes they're required just for filtration, other times for strength and filtration, sometimes for lateral water movement. So it really depends on your particular site conditions. When in doubt, contact our engineering team for a free project evaluation, and we're happy to look at your particular site needs and run the calcs accordingly. Next question, how to install GeoCell on soft soil conditions. No heavy equipment is necessarily required for the installation of the GeoWeb. So you roll out the geotextiles, place your GeoWeb, place the infill, and again, use it as its own access road moving forward with the heavier equipment. We've installed GeoWeb geocells on subgrades as soft as 0.5%, so really soft stuff, and accessed it with heavy vehicles after, so no problem there. Next question, the recommended depth of material over geocells. It typically depends on the application and traffic loading, as well as your final wear surface. General rule of thumb, 5 centimeters, which is 2 inches, or slightly more, depending on the type of traffic. Do you have examples of GeoWeb with gravel installed as shoulders for roadways? Absolutely. Check out the Geo Gallery at prestogeo.com. That's a great solution in that you can vegetate for the shoulder areas and still support your live traffic loading and traffic weights. When used for roadways, is there a maximum grade that can be used? Again, it depends on the conditions. General rule of thumb, typically 15 degrees or less. You can always incorporate some anchorage if need more. Next, is a rock slope comparable and competitive as a type of remediation? It can be, especially if you are talking a mine site and have the waste rock available, like the example I shared. That was actually a nickel mine, the world's largest nickel mine. There it absolutely made sense from an erosion control perspective, as well as an on-site material availability viewpoint. Again, we're happy to run a free project evaluation for your particular project. Next question, can this product be used on up to 75-degree slopes? Very possibly. You want to make sure the slope is globally stable. If not, the GeoWeb earth retention system can be used. And there, if it's a gravity well, we can go nearly vertical. If there's reinforcement required, like grid reinforcement, typically we'll have some kind of setback, which will change your batter to be not so vertical, or at least not 90 degrees. Certainly 75. How would you install GeoWeb along a lakeshore? Would you need to start a layer below the normal lake levels? We do have some great examples of that in our case studies and in the Geo Gallery. If you want to look at those and then see if this looks like something that would apply to your particular site conditions, or submit a request for project evaluation, RFPE, and our in-house engineering team is happy to take a look. Have GeoWeb walls been used in colder climates where you have a lot of freeze thaw? Yes, absolutely. Our global headquarters is in Wisconsin, where we have lots of freeze thaw, and we have wall examples going back multiple decades and can happily point to those. That freeze thaw is no problem. Well, we are already 10 minutes beyond our scope. There are many more questions that I didn't get to, and we will follow up with those as part of the follow-up emails. Thank you all for sharing your day with us and for joining us on today's Best Practices for Installation webinar. Thank you all and be well.